Hello and welcome everyone. My name is Jan Brugård. I'm here today with my colleague Anket Naik to present new libraries and features in System Modeler 14. During the seminar, I will start by giving a brief introduction of System Modeler to those of you that are not familiar to it yet. Then I will hand it over to my colleague Anket, who will showcase the new features. Anket is an applications engineer at Wolfram Core, meaning that he works with the development of models in System Modeler, both for the example pages, but also for our customers through our consulting side. So we'll see if he touches upon anything on his model development part during the presentation. Right. Okay. So System Modeler, a brief introduction. For those of you that don't know it, System Modeler is a tool for developing, as the name says, system models. This can mean, and basically talking about models of dynamic systems, meaning systems that change over time. It could be a mass accelerating or decelerating. It could be some substance being transported through your body. It could be a house heating up or cooling down, etc. And what it has is a drag and drop environment where you can build up your models. Like in this case, you have something from a printing press where a customer was investigating how certain vibrations would affect quality of printing. But could be rather different types of systems than that. As I said, you could use it for cooling and heating also. Here's a model that was developed many years ago by previous Wolfram employee who wanted to understand how to make his house more economic or decrease the cost of heating his house. So he built the model and studied different strategies for heating it in order to save as much money as possible. This is actually available if you go to System Modeler and look for examples and you can download it and look at what he did. But it could also be things like a satellite here where it has developed a model of a satellite and then testing different control strategies to get it to travel around the globe in the along your desired track. So at the end of the day, it can be used for many different things. The key features are drag and drop modeling. And I think that Anket will start by showing you a bit of what that is before he goes into what's new in 14. Then you can quickly simulate and get results for your models to see why is this thing vibrating? Why isn't it accelerating as fast as I want? Or how do I do to optimize the controller, etc. On top of that, it has several features for visualization, adding libraries, and so on. And very importantly, it has a full integration with the Wolfram language, which means you can both actually develop models from a Mathematica notebook and have them work in the drag and drop environment. But you can also take the simulation results in the Wolfram in the Mathematica notebook, and that way analyze the results and try to see how you can improve your system, for instance. So with that quick introduction of the idea behind System Modeler and the key features, I would like to hand over to Anket Naik. So please, Anket, take the floor.
Hi everyone, I'm Ankit, Applications Engineer at Wolfram Core. I have been modeling with System Modeler for the past 5 years and I'm a certified Wolfram instructor. In this webinar, I will present the new libraries and features in System Modeler version 14. Before I start, I want to give a quick overview of System Modeler. System Modeler is a graphical modeling and simulation tool where you create models by drag and drop. Once you create your model, you can simulate and plot the simulation results. System Modeler is tightly integrated with the Wolfram language. Once you create a model, you can do further analysis on the model like parameter sweeps, sensitivity analysis, and uncertainty analysis, among other things. In this presentation, I will show examples from different domains that will give you an idea about where System Modeler can be used. We will start by learning how to analyze uncertainties in model parameters and inputs using the Wolfram language. Then, I will introduce you to the new battery and clock library that are now shipped along with System Modeler. We will then check the new unit handling framework that infers units from model equations. Finally, you will learn how to create configurable installers for sharing your models and libraries with your friends, colleagues, and students. Using the Wolfram language, you can easily understand the consequences of uncertainties in model inputs and parameters. Let me explain what I mean by this using an example. Let's say you have a model for the spread of an infectious disease like COVID-19. Here we have a susceptible group. Once a person gets infected, they move to the infected group, and after recovery, they transition to the recovered group. Alternatively, a person can also transition to recovered group via vaccination. For such models, the model parameters are very uncertain. In this first scenario, you can see how the peak of the infection curve varies as the reproduction number is varied by 20%. Similarly, in the second scenario, you can see how the infection curve shifts as the infection period parameter is varied by 40%. The thick blue curve shows the median curve, and the lighter blue fillings show the spread. You can use these uncertainty plots to quickly observe the best and worst case scenarios for a given uncertainty in model parameters. Using these uncertainty plots, you can also check if your system has enough margins. For example, here you can see that for certain parameter values, the peak of the infection curve goes beyond the available healthcare capacity. Let's go through the workflow to create such uncertainty plots. Here we have a model of an RC circuit. Such circuits are used as filters or to add artificial delays in an electronic circuit. For such applications, it is important to understand how the circuit responds to a voltage input. In order to use the uncertainty plot, we will use the new Wolfram language plot function called System Model Uncertainty Plot. This function takes the model's name as the first parameter. We need to define the parameter name that is uncertain as well as the range of its variation. The function then creates 200 simulations by default and runs them in parallel. It then compiles the results and presents the uncertainty plot. This gives us the best and worst case scenarios for our chosen range of variations. Rather than range, if you are interested in the likelihood of the model result, Then you can also provide a distribution. Here we have used a normal distribution for the resistance value. We have truncated the values of the distribution to match the manufacturer's tolerance range. You can observe that the spread is less in this scenario. Not only parameters, you can also add uncertainty to model inputs. In this example of a speaker model, the input voltage to the speaker model can contain high frequency noises, as shown in the following plots. We can provide a list of these inputs to the speaker model and check the range of variation of the current in the speaker circuit. You can observe that because of the noises, the current in the circuit varies by about 5 milliamperes. As we transition towards a sustainable society, the role of batteries becomes more important. System Modeler 14 comes with a built-in library that will enable you to create large-scale battery models. Let's check an example where these battery models are used. Recently, we created a model of a self-sufficient building that is completely reliant on power from solar panels. The energy is stored using a combination of 3 batteries. In this example, a switching logic was tested for the charge and discharge of the batteries based on their state of charge levels. Similarly, battery models from the batteries library can be used to test designs for battery packs, let's say for electric cars and commercial energy storage systems. Or it can be used to create battery management systems for drones. Let's look at an example. Here we have a model of a battery management system for drones. Let's open the model in System Modeler. You can see that this model consists of 3 subsystems: an electric circuit, a thermal subsystem, and one subsystem to monitor the state of charge of the batteries. The electrical circuit is missing the battery model. Let's add it. The battery models can be found in the electrical package. We will use a model from the battery stacks. We will use the cell stack component. Drag it on to the model and connect it to the electric circuit. The only parameter we have to specify is the cell data parameter. It uses the cell data record that I have already created. This record specifies the cell properties like storage capacity, internal resistance, and open circuit voltages at different state of charges. Your battery management system is almost ready. While using batteries in real life, for example, while using your cell phone, you might observe that during certain usages, your battery generates heat. These battery models also contain a heat port through which the heat generated through the internal resistance of the battery can be transferred to the thermal subsystem, and a thermal management system can be designed. We will set the use heat port to true and connect it to the thermal capacitor that represents the body of the battery. Our battery management system is now complete. In the following example, we have used the battery management system in a drone model. Let's simulate the model and observe the results. The drone follows a reference trajectory. You can visualize it using the animation window. You can then plot the state of charge of the battery during the entire operation. You can also plot the temperature of the battery. Lot of real-world applications are discrete in nature, which involve periodic sampling. For example, let's say you're controlling the temperature of a room and you're using a digital temperature sensor to monitor the room temperature. A digital temperature sensor samples temperature not continuously but every 5 or 10 seconds. Measuring it continuously will require very high sampling, thereby consuming a lot of energy, and such a sensor would also be very expensive. The clock library provides components that makes modeling such sampled systems really easy. Let's look at an example from industry. In the process industry, it is common to have mixing tanks. In these tanks, concentration of the substrate and the temperature is controlled using feed-forward controllers. The components from the clock library are used to sample the temperature and reference values. It is also interesting to note that two different continuous subsystems, that is the controller and the tank, are connected by the components from the clock library, which is discrete in nature. Clock library can also be used to create systems with different sampling rates. Let's look at an example. Here we have a cascade control system that controls the angular movement of the shaft. For such applications, two different types of sensors are used. A high frequency gyro sensor is used to measure the angular velocity of the shaft, whereas a low frequency sensor is used to measure the angular position of the shaft. Such a system with different sampling rates can also be modeled using the components from the clock library. Let's check this example in System Modeler. The clock library is found under the Modelica library. It contains different types of clocks. These clocks can be triggered periodically, or they can also be triggered when an event happens. The library also provides various samplers like subsample and supersample that slows and fastens the sampling with reference to a master clock. These samplers are also used in our example. Let's simulate the model. The angle of the shaft follows the reference angle. If we zoom further, we can see that the fast controller and the slow controller are sampled at different rates. System Modeler 14 comes with hundreds of new units and unit conversions. You can also switch between unit systems like SI, imperial, or a unit system of your choice. I will share a video that summarizes a problem that we are trying to solve.
I have no word for that.
Seems like we should have a word for 1,000 pounds, sir.
And yet we won't. Because we are free men. And we will be free to measure liquids in liters and milliliters. But not all liquids, only soda, wine, and alcohol.
Only those, sir.
Yes. Because for milk and paint, we will use gallons, pints, and quarts, God willing.
Okay. How many liters are in a gallon, sir?
Nobody knows.
Indeed, units are confusing. Let's look at how we are making it easy to handle units. Let's look at an example of a drum boiler used for generation of steam. As I mentioned earlier, System Modeler version 14 comes with hundreds of new units and unit conversions. To use it, simply write the parameter value with your unit of interest. If the unit information exists, then your value is automatically converted to the display unit. Here, let's specify the volume as 25,000 UK gallon. System Modeler recognizes this unit and automatically converts it to cubic meters. In version 14, units are also automatically inferred for the model variables. For instance, the outputs liquid volume and mass flow steam are not assigned any units. But when you simulate the model, their units are automatically inferred. Finally, you can also switch between unit systems like SI, imperial, or any custom unit system. To switch to a different unit system, simply go to Tools, Options, Display Units, and select the imperial system for instance, and deselect the other options. All the plots and model variables will now be in the unit system of your choice. With System Modeler, you can create installers for distribution of your libraries. In version 14, you can configure these installers such that they behave as model files, as that will allow your library users to modify and update the local copies of the library. Let's look at an example. Here, we will create an installer of the drone library. You can create an installer by exporting a library as a library archive. Give it a name To make the archive behave as a model file, simply check the option Make libraries load without installing them. You can also add a library license. Click OK. Your library users can now easily install the library. They can also modify their local copies of the library. So far, in this presentation, we have covered the key features and libraries of System Modeler 14. There are some other features and libraries that I also want to quickly mention. With version 14, you can customize the visualization of all your plots by adjusting the global setting for plot themes. You can also add logarithmic scales for your simulation plots. Rotating Machinery Library was recently released and we are going to have a webinar on it in a couple of weeks. This library allows you to test novel designs or identify faults in rotating machinery such as turbines, motors, and drivelines. You will find fundamental components of rotating machinery such as gears, shafts, and bearings. These components are designed to be flexible, enabling you to observe deformations and accurately capture real-world responses under different loads. Here is an animation of a planetary gearbox from the Rotating Machinery Library. Here you can observe the contact forces acting when the gear tooth contact each other. You can use the library to model bearings and use it for frequency analysis as shown in this example. Version 2 of the aircraft library will be released soon. It has components that can be used to model quadcopters like drones. Here is an example of a 76 rotor drone created using the library by Aerial Industries Private Limited. They use the library components to create this large-scale model and are using it to design controllers. Let's look at its animation. Finally, here is a built-in example from the library that models a drone following a reference trajectory. Let's look at its animation. This library will be released very soon. I hope this presentation gave you a quick overview of the new features and libraries in System Modeler 14.
Okay, so let's start with this one. Can the simulation results be embedded in a Mathematica notebook? If so, do the units carry over? Do you have an example of that in
Yes,
the notebook?
yes, we can try. So, okay, let's. So here is a example of a DC motor in System Modeler. Let's try to plot this in the Wolfram language. I will just zoom in my screen so it's visible. I can do system model plot of this of DC motor, and you can see when I'm plotting it, the units for the motor speed that was in radian per second and the unit for the voltage that was in volts is carried forward, and you can plot it in Mathematica.
Right. And then, of course, you can do a lot more once you have it there.
Yes,
In essence, one could say whatever you typically do in Mathematica with other things, you can do with a system model results. I guess is a good
yes,
summary.
yes. So what happens is if you do system model simulate of this example, like this, it will give you a system model simulation data object. And let me open the documentation for it. Yes, it's opening soon. And once you simulate a model, you get this system model simulation data object. And here you can see an example where you can access the any model variable of your model, and then you can get an interpolating function out of it. So you can get it as either as an interpolating function, or you can get it as a time value pair, and then you can use that data with all the other functionality in the Wolfram language.
Right. So let's see. Next question here. Well, there was one related to it, and I think I can take that one. It was if there are any overlaps between Mathematica and system model regarding usage, licensing, etc. And yes, of course, there are. You see here for instance, the ability to simulate a system model within Mathematica. You can do that. That actually does not require that you have a system modeler license. You can run that in Mathematica regardless of having a system model license or not. You just need access to that model, and then you simulate it. And actually, all the built-in system modeling functions in Mathematica, you can run them with Mathematica itself without having a system modeler. Perhaps you can open that guide page or that help page just to see what's available on in the Mathematica environment when it comes
Yes,
to
yes,
specific system modeling commands.
yes. I think it should be. Um,
Putting you on the spot here.
System
Yeah,
small.
so here you can see some of it, I guess.
Yes,
Let's see.
this one is what you're looking for, I
Yes,
guess.
exactly. So here you can see that there are in different sections, for instance, with simulation, we have something called system model simulate, system parametric simulate, and what you saw in the beginning was the uncertainty part of it. So all these functions that are in Mathematica, you can run them without the system model license. If you have the system model license, then you can go back and forth between the two environments, bringing in results from system modeler. So for instance, if you have plotted something in system modeler and want to bring it in Mathematica, then you can copy and paste it. That's one of the ways. Perhaps that's also something you can actually quickly show and get if you have a simulation
Yes,
available.
yes. So let me So here, you mean the
Yes,
object?
exactly.
Yes. So we have this vaccination simulation results here, and I can copy it as a Wolfram object by clicking this option here, and then I can open up my Mathematica and uh, paste it here. So you see, you get the same simulation data object, and once you get this data object, as I showed you before, you can access all the model variables as interpolating functions or a simple a list of time value pairs.
Right. And in general, there are all sorts of functions for this. If you have created a neural net in Mathematica and want to have that as part of a system modeler model in the drag and drop environment, then you can import that to system modeler and you have it there. So there is an integration, but you can also run both softwares standalone.
Yes. Can I
Uh,
add something to that, Jan?
yes, of course.
So also, you can use system modeling functionality in the cloud. So let's say you have created a model, you can upload the model as a cloud file, and then you can use the cloud from cloud to play around with the system modeling functionality. So that is also possible.
Yes, and there are ways. Also, if you want to publish them with interactive with manipulates, then there are
Yes.
actually you have there is a resource function to create manipulates directly from system models that might be interesting for people to know and that they might not be aware of.
Yes.
So for those of you that don't know the while Ankit is showing this that don't know the resource functions, it's a way where you as users can publish different additional functions to the Wolfram language that do different things. And one of those done by one of Ankit's and my colleague is called system model manipulate. And so
Yes.
now Ankit will take a model here that happens to have is in system model here. Okay, so it's the satellite example. And here you can see that he has it. He takes the resource function system model manipulate and just asked for that model. And what it does then, it will compile, simulate that, and create and manipulate for it. So we should be seeing it soon. What's saying there, Ankit?
It's saying it's in progress.
It's in progress. Okay, so yeah, there you go. And now you have so that way you can benefit of having set it up quickly in system modeler and then get it interactive inside here.
Yes. So if you are if you're sharing your model with someone who doesn't have system modeler, then you can make use of the cloud and they can play with the results. Yeah.
Right. So let's continue something completely different. There were a couple of questions related to the functional mockup interface, which is a standard to share your models from one tool to another. And there's a standard supported by System Modeler. And the two questions were: I understand cooperating using the functional mockup interface, but is it also possible to cooperate with people that use, for instance, Open Modelica, exchanging Modelica code? And the answer to that question is yes. So you can, and I'll ask Ankit to show a bit of the Modelica code soon. And then the other question was, can you keep your own model content confidential if you deliver it in order to use it as a black box? And again, that the best method to do that is to use the functional mockup interface and functional mockup units. So to answer this, let's start by giving I think if you give that, you started to show how to find out more about FMI, Ankit. So perhaps you can show that part.
Yes. Okay. First, let me start with FMI. So, if you are interested, we have got this question so many times, and it's so important that we have a dedicated page for it for people who want to know more about it. And you can find it under our resources
Yeah, can you?
page.
But you can copy it and post it in the chat, I guess. There.
Yes, and here it has quick videos on what is FMI. So for people who are listening it for the first time, we have created two short videos on what is FMI and how can you use and why should you use an FMU. And here, as Jan said, it shows the different formats in which you can exchange files. So there is one format where you hide all the code, and there is another format where you can like a tool is where you can show the code in some way in a model exchange format. So you can view this, you can go through this resource, and it will give you all the information on that.
Good. And then if we look at the sharing with Modelica, perhaps just showing,
Mhm.
just show the Modelica code of this,
Yes.
so people can see how it looks like.
Yes. So when we drag and drop components to our model, what happens behind the hood is in the text view, what we do is we just create instances of the different components. And it's basically, it might look a lot of text, but it's very simple. It's basically declaring the different types and then having some connect statements. And this is a open standard language called the Modelica language. And like the FMI page, we also have a Modelica page for people who are new to this language. They can read about what is Modelica and why should what's the benefit of using Modelica. And the question on if a model can be used with Open Modelica. So Modelica also works similarly to System Modeler. So when you create models in Open Modelica, it writes the Modelica code behind. So you can easily share your models among Modelica tools. So if you create a model with System Modeler, you can easily share it with someone who is using Open Modelica. So yeah, there is
Right.
tool interoperability.
Yeah. And now where we'll add it with there are a few other Modelica related questions as
Mhm,
we ended up there,
mhm.
or Modelica and library related. Which one should I start with? Um, let's okay. Let's start with this one. When simulating mechanical systems, how can one specify the geometrical object, like the drone example, to be used in the dynamical graphical window simulation? Perhaps you can show something from that very example, or from something similar.
Yeah, sure. Let me try to open the model. So I think the chassis will be uh, okay. This one is more advanced. I will pick something more easy. Um, yes. Um, right. So with Modelica, there is Modelica comes with a mechanics package, and inside this mechanics package, you have this multi-body library. And using this components, you can create mechanical systems. So to start with, I think it will be better to show an example from here. So here is an example of a double pendulum where we have a world component. It's basically a fixed wall, and to this we have a revolute joint to allow this rotational motion, and then we have uh, a body box, which is basically a cylindrical component, and then another revolute and a body box. So this is basically a simple mechanical example of a double pendulum, and let me
Yes, if you
simulate this.
share a bit,
Right.
because to stay with the question. So the question was, how do you choose the type of shape, for instance? And
Oh,
with that
right.
selected, you can show that there is a drop-down menu here, basically, where you show.
Yes. Uh, yes. Should be maybe not this component. Uh, right.
Right, there should be. We're not finding it right now. There should be
Right.
one that
Yes.
there. Yeah, there you go. Right. So
Uh,
where you isn't that it was. I'll look for it and get back to you with it.
yes.
Um, but you can choose between different predefined shapes.
Yeah.
But if you're not happy with those, then there is ways to create your own using CAD shapes, for instance. I can post a link to a blog on the Johnny Beck of Effect where we illustrate this very well. So I'll do that in a bit. Um, Instead, let's because we have a lot of we have quite a few questions unanswered yet.
Yes. Okay.
Um, So I'll send the link to that.
Yep.
There was a question here. Have you worked on general thermodynamics component like the proposed Modelica prop for thermodynamics and transport? It would be good to interface to Wolfram.
Right. So again, the Modelica library comes with a media package, and it has different models of fluids, like for instance, simple air. And this fluids have all the thermodynamic properties, like uh, how the density changes, how the kinematic viscosity changes with temperature and pressure. So here is a so we provide with a collection of this medias, and then we have a fluid library. And let me bring up an example here. So here you have a model of a heating system. We have a tank, a pump, and all. And in this pump, if you select a pump, you can select between like uh, uh, around hundreds of pre-made, like hundreds of available medias that you can select. You can select between different ideal gases, and also you can select between different types of fluids, like the thermal oil and other things. So yeah, we have and so we provide this media library with the collection of different medias. And also it is possible, if you have the thermodynamic uh, properties of a new fluid or a fluid that you're interested in, then it is also easy to create a new media uh, using this structure. So you can also add new media if you need, if there is a need for it.
Good. Okay, let's move on and take the last. I think for now the last Modelica related question. You were showing a bit about the SIR, so there came a few questions relating to that, and also about what we have in for ecological and biochemical reactions, and etc. So I guess perhaps going to the library page is a good thing to do to show this,
Yes.
and showing the business simulation and the biochem libraries, which are those most related to it.
Yes, I will start with biochem because Jan, you know more about it.
Right. So of course, there are many different directions to go with the modeling. I happen to have done a bit of modeling with of biochemical systems,
Yeah.
meaning systems like metabolic pathways or modeling how to produce bioethanol and so on. So this library has basically substances, different reaction types, different compartments, and so on. So you can build models. So if you click on, yeah, take that example. Doesn't really matter which one. Yeah, okay. So this is one from a blog where, and if you scroll down, there you have it, and we zoom in a bit to it. Right. So here is one simple process where we have two sugars, glucose and maltose, on the left coming in to the system, and then there are some reactions going on. And we can see that on the right-hand side, on the middle right-hand, there's a biomass. Below it, there's oxygen. And the purpose on this one is to produce ethanol, which you see down at the bottom, the furthest down of the green blobs. And the way you do that is basically by controlling the amount of oxygen that you add to the system. Um, it's a very similar process of actually baking bread. So when you want your bread to grow, what you basically do is it's the very same process. You have yeast, you have sugars, and then what you do there is you add a lot of air. You have it out in air, and then it grows. In this case, instead, what you want is to create using similar process, but you want to create ethanol. Then you have to kickstart the process with some oxygen, but then basically shut it down to a minimum, and that way this sort of reaction chain will produce ethanol. So this library is used for those kind of systems. And then we have another library here, business simulation, that I guess Ankit can cover a bit. Perhaps the SAS model there is a good one.
Yes. Okay. So basically, if some people in our audience are familiar with system dynamics metaphor. So this business simulation library is based on the system dynamics concept, where you have stocks, you have flows, and you have and you model any dynamic system using stack and flow concept. Uh, and to start with, I will get back to the SaaS model, but just to show this, to show the concept. So if you want, so you can use this library to model the SIR model that I showed uh, during the presentation, where you have a susceptible stock, and then you have susceptible, infected, and removed stock, and the transition between these stocks is by some rate components, and you can have linear flow, or you can have a custom rates. You can define those rates.
Right.
Uh,
And the stocks you mentioned here, they could be anything. Now you said they were susceptible, so but they could basically be in something related to some ecological process, like the
yes,
amount of some species or
yes.
whatever. Right.
So
Yeah.
basically, like a prey predator model, you can also model using that. And I did something very different with this using this library. So what I did was, in one of our blogs, I was curious enough to understand how a software as a service company operates, and trying to understand the business of it. And then I modeled a sales funnel. Like in a market, you start with a group of unaware customers, and you do some advertisements, and that helps in transitioning unaware customers to aware customers. And then with some use cases, they become trial customers, occasional customers, repeat customers, and so on. So using this stock and flow concept, I was trying to model how a market or how a sales funnel would work, and those kind of models I was able to do with this business simulation library. And the thing is, since all this are blocks, you don't need to know, you don't need to use any equations. It's just drag and drop, and then trying to use this stock and flow, like a pump and tank concept, to model some things like this.
Right. But when you mentioned that, in this case, it was just you just drag and drop, and it creates the differential equations for it. One of the questions was actual, how do you create those equations, which of course gets back to the Modelica
Right.
concept and the models. How can you show a bit how it's done?
Yes. So, as you said, there are various ways in which one can create model. The first process, of course, is you can write your own code, Modelica code, and you can write it. But I think the easy process is you can also use the Wolfram language to create your model. For instance, here I have a model of a predator prey, and here you can see that we have defined the equations, like the derivative of the population size is equal to the rate, and then we have defined some initial equations, and then we have created a model from that. So you can use differential equations uh, in the Wolfram language and create a system modeler model from it. And the function that actually helps you do that, and also you can learn more about it, is this create system model function. So this what this function does is, it takes, let's say, if you are from the control domain, and if you have a state space model or a transfer function model, it creates a model out of it. Or uh, in the scope, if I go for differential equations, so if you have your own differential equations, it creates a system model out of it, and then it creates a block, and then that block you can then combine it with the other hundreds of blocks in system modeler, and then create your nice graphical model using this. I just
Let me
wanted to inform
right.
guys who are new to System Modeler that in WolframU we have this the modeling and simulation category. And here, if you want to know more about System Modeler and its integration, you can review this courses here. Also, um, one thing that I would recommend is we have this Wolfram System Modeler for engineering study group sessions. I personally feel that these are really nice for people who want to know about System Modeler. So it's a collection of like 9 hours of training on System Modeler, and it goes through different examples from different domains. So if you want to dig deeper, look into more examples, then following this study group sessions would be really nice.
Right. So let's wrap up then with a couple of more here, and there's one question: if there's a blog comparing system modeler to Stella, and then specifically what's interesting there is the business simulation library to Stella, because Stella is a system dynamics package, so it's limited to that set of domain. What I think is the last question: will there be a connection in the future to the Wolfram curated database of materials, say for the fluid library? That's a really good question, and of course, it's something that is of high interest to see how that should be done. So I don't have an answer of that specifying when it will be available. I can tell you that it's an interesting question.
Yes, it's an interesting question, and I also have not looked into it, but it's really nice
Yeah.
because we have this interfaces for our media library, and perhaps there is a way of quickly creating some fluids from it, but I have not explored it
Yeah.
yet.
So that's a bit. There's a lot of ongoing around the fluids and medias at the moment, actually. So you will be seeing different things there.